Hi guys, today we're going to talk about manufacturing productivity rates. Now, most companies when they do this type of analysis will analyze their production levels from day to day, week to week, month to month, quarter to quarter. But what I like to do, it's something I do directly with my customers, my own customers, and with the consulting companies that I work with. What I like to do is actually analyze manufacturing productivity rates in an individual workstation. Okay, so in this case, we're going right to where manufacturing is occurring, right in individual production work cells. And the reason why we do that is when you look at a finished product, okay, there is a cycle time to manufacture the finished product. And that cycle time includes transit times between individual workstations, and it includes the cycle times to do different operations inside of those workstations. So I like to analyze these cycle times and the productivity rate exactly at the workstation itself because, to be quite honest with you, it gives you a clear picture of what causes lost time. The other reason why I do it is because a lot of my customers seem to have a hard time reconciling the amount of production they get out of an 8-hour work shift. Okay, so a lot of times I get hired because customers are looking at the production levels and they can't make heads or tails as to why they're not getting as much production as they think they should out of a given work cell or what have you. And there's a couple of reasons why that is. Now, they're not looking at the amount of time that is actually being worked on. Okay, so today we're going to take a very simple and systematic approach to figuring out the productivity rate in a given work cell. And then we'll just kind of backtrack it into the cycle times of the operations in that work cell. Okay, so we'll start off with the 8-hour work shift. So you've got 8 hours in a work shift, and we all know nobody works a full 8 hours. It's not possible. So in our example, we're going to take off 1 hour for lunch. Okay, so right away, whoever's working, he or she in this production work cell is not working 8 hours. They're actually working 7 if possible. We know that's not quite possible, so we take off another 2 15-minute breaks, okay, one in the morning, one in the afternoon. So now we're left with what looks like 6.5 hours of actual work time. Now, again, nobody works a full 6.5 hours. It's not possible, okay? So what we're trying to figure out here is, in this given work cell, what are the causes of downtime that stops someone from working this full 6.5 hours, okay? So no one can work a full 6.5 hours because they're not machines. So we want to figure out what amount of work is actually being done. So I actually did an analysis for a customer recently where I looked at the workstation, a particular workstation, and what we found was over a period of about 5 days, we had about 135 minutes of lost time. Okay. Now, there's a lot of reasons why this lost time occurred. A lot of the times there were issues pertaining to bill of materials. We had issues pertaining to assembly drawings. So there was a vast number of issues that caused this 135-minute downtime. But again, even in the 6.5 hours, people, they need breaks, they need to go to the bathroom and everything else. But in our analysis, we found 135 minutes of lost time, which related to several different factors. And if we convert this 6.5 hours into actual minutes, we're actually talking 390 minutes. Okay, so the idea is that of the 6.5 hours, which is actually 390 minutes, we had 135 minutes of lost time. So when we take that away, right away you're left with 255. So we had 255 minutes of actual work time. Okay, so you go from 8 hours, you take off an hour for lunch, you take off 2 15-minute breaks, you're left with 6.5 hours of actual work time. You actually analyze the lost time in the workstation, and in this particular example, I came across 135 minutes of lost time. Not the employee's fault by any means. A lot of issues pertaining to that: bill of materials, assembly outlines, poor construction drawings, incomplete work orders was another issue. And you convert this 6.5 hours into minutes, which is 390 minutes. You minus the 135, you're left with 255 minutes of actual work time, which, if you wanted to convert back, is 4 hours and 25 minutes of actual work time. Now, in order to determine what your manufacturing productivity rate is, you simply take the 255 and you divide it by the 390 minutes, and that gives you 65% productivity rate in this particular workstation. Now, depending upon where you are, what country you work in, the type of manufacturing you're doing, this could be high or low. So it depends on the situation. But to give you an idea, I have actually worked with a number of different clients that have had productivity rates at around 50%. And once you get past 50% productivity rate, usually the downtime is caused by a number of different issues. But when you get to this point and you got your 65%, you're trying to figure out, okay, well, what is my actual production in terms of units? What you would do with this is you've got actual 4 hours and 25 minutes of work time, or 255 minutes. Let's say your cycle time is 15 minutes to manufacture a given unit. That means out of the 255 minutes, you're probably producing, I think, if you take 255 divided by 15, you're like 17 or 18 units. Okay? So typically what happens is someone looks at the 8 hours, they say, you know what, it only takes us 15 minutes to manufacture this given product. How come we're only making 17 or 18 units? And what you have to do is you have to do a systematic analysis of what the actual productivity rate is in this work cell. Once you do that, you take an hour off for lunch, 2 15-minute breaks, gives you 6.5 hours. No one works a full 6.5 hours. Track the causes of lost time as it occurs, bill of materials, assembly outlines, look for things relating to poor work orders, lack of tools, even production bullies on the shop floor. We all know politics plays a big role in terms of manufacturing. Now you convert the 6.5 hours over to minutes, because in this particular case, we did it by minutes. Cycle time was measured in minutes. 390 minutes. We minus the 135 in terms of lost time. We're left with 255 minutes of actual work time, 4 hours and 25 minutes. Divided by our cycle time of 15 minutes gives us 17 or 18 units. So that's it. Thank you very much.